All right, welcome guys. Today's lesson's on multiplying binomials. We're going to do just a little bit of review of what we talked about previously, and then just jump right into it. A couple things just to kind of highlight for today. First off, objectives. We want to be able to feel comfortable multiplying binomials, which has just a little bit of a review is just a two-termed expression. Using any method of your choosing. We're going to teach you three and let you kind of choose which one fits your eye, so to speak, the best. We'll get into maybe a little bit more complex ones where we're multiplying binomial expressions by trinomials, and then understand what it means for these to be fully simplified and kind of just feel comfortable multiplying a two-termed expression by anything, really. Okay. Now, last week or last lesson, what you guys focused primarily on were monomials. Okay, this is an example of a monomial. Okay, it's just a one-termed expression. It's a combination of a number like 2, a number and a variable like 2x, or a number, a variable, and an exponent like 2x to the third power. And what you guys did was we practiced kind of distributing this through and essentially going through some of the basics, not only of monomial multiplication, the distributive property, but also in multiplying exponents. Okay, 2x to the third power multiplied by 3x would be the same as 2 times 3 with essentially 4 x's. So 6x to the fourth power. 2x to the third times 4 is the same as 2 times 4, or 8, with that x to the third power attached to it. And then 2x to the third times 2x to the second is 2 times 2, or 4, with, let's see, 1, 2, 3, 4, 5 x's. And so this expression, when reordered, would represent that product, 6x to the fourth and 8x to the third power. So really just trying to get you guys comfortable with kind of the language of bi and trinomials, and also the language of multiplying kind of goofy expressions by other goofy expressions. All right, so this was kind of what we did last week. The other thing we focused in on was how to essentially reverse that process and factor it. But we're not going to talk so much about factoring today. We're going to talk more about multiplication. All right. Now, one of the first ways I learned how to multiply, okay, was to break numbers down. Okay, to break numbers up. Let's say that we wanted to multiply the numbers 24 and 16. Okay, now the standard algorithm is to kind of work from top to bottom and do 4 times 6, which is 24. Put the 2 up here and kind of work it that way. Another way to do this multiplication is to basically identify it kind of like an area model. Okay, where the 24 could be written as the sum of 20 and 4. The number 16 could be written as the sum of 10 and 6. And then really just finding the area of each square. Adding them all up, you got the multiplication. 20 times 10 is like 200. That's an easy multiplication to do. This value of 10 would be transferred here. 10 times 4 would get you 40. So right now we're at 240. 20 could be transferred here, and 20 by 6 box would be 120. And then 4, which could be transferred here, a 4 by 6 box could be 24. So another way of multiplying is to just add up all these partial sums. 200 plus 40 is 240. 240 plus 120 is 350. 200 plus 240. That's 360, and 360 plus 24 is 384. Hope I did that all right in my head. But one of the first ways that I was learning about two-digit multiplication was to write it out this way. All right. Now, as we're doing that, essentially what happens is the 20 multiplies by everything. Okay, it multiplies by 10 and it multiplies by 6. The 4 also multiplies by everything. The 4 multiplies by 10 and the 4 multiplies by 6. So when you're multiplying two-digit numbers, essentially what you have to do is just make sure that everything multiplies by everything. okay? Now, this is kind of what we're going to be working on today, only with just a little bit more complex expressions, right? We're going to be focusing on how to multiply something like 2x plus 2 by something like x plus 3, a binomial times a binomial, right? And there's a lot of different ways to do this. What we're going to do is focus in on 3 techniques. The first one is kind of a distributive property technique. The second one is an area model, and the third one is going to be what's called foiling, which you guys will see exactly what that means, right? Now, there's a whole bunch of mumbo jumbo that we'll maybe just learn through the actual working out of problems. We can come back to this if we want to, but we're going to just start up with a distributive technique, all right? And what the distributive technique basically says is we can break this into 2 different problems, all right? We can have 2r that's then multiplied by the entire thing, r plus 1. And we can also have negative 3 multiplied by the entire thing, r plus 1, right? And once we combine everything, we've got our actual product. So 2r times r would get us 2r to the second power. 2r times 1 gets me 2r. So in that first distribution, this is what we get. Second distribution, negative 3 times r is negative 3r. Negative 3 times 1 gets me minus 3. Okay? So what we can do to multiply these 2 binomials is to just do it in this way where everything in one binomial multiplies by everything in the other. Now, there are some things that can potentially combine, like positive 2r and minus 3r. 2r squared is kind of on its own. 2r to the first minus 3r to the first is going to be a minus 1r and minus 3. This would then be my product. Right? This would be multiplying the binomial on the left side by the binomial on the right side. Okay? So distributive property works nicely if it works in your head, if it makes sense in your head and you want to use it. It's a great technique. Okay? 2x has to multiply by everything over here. 3x minus 4. We can distribute this through. 2x times 3x is 6x to the second power. 2x times minus 4 is minus 8x. Second thing that has to happen is that 7 must also multiply, change colors here, 7 must also multiply by 3x minus 4. All right, so you take 7 times 3x, that's 21x. 7 times a minus 4 is minus 28. So then when you combine this expression here with this expression here, we've got our answer. 6x squared minus 8x plus 21x, which will combine, and then minus 28. Now you see that these 2 terms are alike. We do want to put those together to make 6x squared. Let's see, negative 8 plus 21x is plus 13x and minus 28. So this would be our completed product. Okay, is the expression that's actually 100% equal to that 2x plus 7 times 3x minus 4. So this is using the distributive property technique. It's fine if you choose to do it. Okay. Another technique for multiplying binomials is the table technique. And this is how this would work. All right. First thing that you do is you just label each side. We're kind of thinking of each expression as like the length of a rectangular square. So we're going to call this x, this minus 8, this 3x, and this plus 1. Okay, we're going to kind of ignore these outers for the time being and just find the area of that square. Well, if you took 3x times x, that's 3x to the second power. If you took 3x times a minus 8, that's minus 24x. If you took x times 1, that's just plus 1x. And if you took 1 times negative 8, that's minus 8. So this is another technique for multiplying, is to essentially treat each binomial, like the length of a rectangle. Length or width, I guess. So the things that are alike, 3x squared is all by itself, the minus 24x and the positive 1x can combine to make minus 23x, and then the minus 8 is kind of standing by itself. This will be our product. All right. So again, a different way of multiplying, and that way of multiplying works for anything. Just like the example that we gave at the beginning, where we're actually multiplying like 24 and 16 to get 384, you can break things down. Use an area model and it works just fine. Let's try another example using that technique, because it may be something that you like, I don't know. So we've got one length, let's call this the length, so 2h minus 7. You can think of that length or width, I guess. Width here, h plus 9, so h and then plus 9. So to find the area, again, 2h times h, that's 2h to the second power. This h times a minus 7 is minus 7h. 2h times 9 is plus 18h. You guys can see we're just essentially filling in the box. We're ignoring these ones, don't need them. 9 times a negative 7 is minus 63. I think these two terms will combine because they're alike. Again, same variable parts raised to the same power. Our final product then is 2h to the second. Let's see, 7 less than 18h, that's plus 11h, and minus 63. So again, one other way to multiply binomials by binomials, the biggest thing again is understanding that everything has to multiply by everything, okay? 2h had to multiply by h and by 9. Negative 7 had to multiply by h and by 9. So if you like tables, so you like to see your multiplication a little bit clearer, by all means, use a table. Now, this is probably the technique that I want you guys all to get to, is the FOIL technique, all right? Now, FOIL is an acronym, and it's an acronym for first, outside, inside, and last. Okay, this is what the FOIL method does. Let's take just a really simple one like x plus 1 and multiply it by x plus 2. Right? The F for FOIL just stands for the fact that we want to take the first term in each binomial and multiply them. Okay? First. Okay, so we're going to take x times x. The outside means we're going to take the outside terms and we're going to multiply them. Outside. So we will take x and multiply it by 2. Right, or 2 multiplied by x. Inside is going to be the 1 by the x. This is the inside. Okay, so we're going to add to this 1 times x. And then last is the last term in each binomial. So 1, oops, I'm going to keep my color scheme going here. The 1 must multiply by the 2. That's the last. Right, when you simplify this all, x times x is x to the second power. X times 2 is 2x. 1 times x is just x. And then 1 times 2 is 2. Combine those middle two terms and we've got our product. X squared plus 3x plus 2. All right. So as I said, FOIL is kind of a noun and a verb. Right. We're foiling, but really in the grand scheme of things, what we're doing is multiplication. All right. First, outer, inner, last. I also call this the claw method. Because if you look really deeply, you can kind of see a claw hand there. All right. The claw method works just fine. FOIL method, whatever you want to call it, works. All right, so we're just going to get some practice in actually using this FOIL method today. So 3x plus 4 multiplied by x plus 2. First terms times first terms. 3x times x. All right. That's going to get me 3x to the second power. Outer terms, 3x times a positive 2. 3x times 2. That's going to give me plus 6x. Inner terms, 4 times x. 4 times x. 4x. Easy enough. And last terms, 4 times 2. Okay, again, easy enough, that's 8. When you look at it, look for your like terms. You got 6x and 4x can combine. Final product for this one is 3x squared plus 10x plus 8. Okay, that's the FOIL technique. It's really simple. Again, you'll start to notice a little claw up top. Lobster claw, right? Can make it a little bit of fun. But what the FOIL technique really does is it just multiplies. Okay, it's just multiplying numbers. Now, what we're dealing with are a little bit more complicated than numbers, but when it comes to just simplification, that's all we got. All right. Let's try a couple more examples of this. Again, watch out for signs. If you see subtraction symbols in there, I think it is kind of helpful when you're dealing with these to add negatives, just to keep the signs straight. So we've got n times 4n, that's 4n to the second power. N times negative 7, that's minus 7n. Negative 6 times 4n, that's minus 24n. Negative 6 times negative 7 is going to be a positive 42. Combine the middle two terms, and you're done. 4n to the second power. Negative 7 minus 24 is minus 31n, and then plus 42. FOIL. First, outer, inner, and last. All right, why don't you guys pause the video, or if this is Edpuzzle, I think we'll probably have you guys try this on your own. All right. 3x times x, 3x squared. 3x times 4, 12x. 1 times x, 1x. 1 times 4, plus 4. Middle two terms combined. 3x squared plus 13x plus 4. Done. All right, again, no like terms. If you see like terms, combine them. If you don't see like terms, you're good. Again, pause the video. Try it out on your own. Two h times h, 2h times h, 2h times 9. That's our first and our outer. Inner terms, negative 7. Remember, it is a negative that's being distributed. That's negative 7 times h. Negative 7 times 9. When we simplify this, 2h times h, that's 2h to the second power. 2h times 9 is 18h. Negative 7 times h is minus 7h. Negative 7 times 9 is minus 63. Combine your middle two terms, 18h minus 7h. Final answer, 2h to the second plus 11h minus 63. All right, once you get a hang of this, they just flow. They're really easy. Trinomials by binomials. Again, general principles. Okay? Everything over here has to multiply by everything over here. All right? One thing I like to do is I like to start with my binomial, or at least with the shorter term. So x minus 3 is a shorter term. There's only 2 terms to it. It's binomial, and then I like to, kind of just reorder it this way: 2x squared minus 3x plus 1. Because when I do that, I only have to distribute or FOIL once. So general principle is that this x must multiply by everything over here. So this is kind of like a mega claw. The -3 has to multiply by everything down here, okay? So you can see it's still FOIL, even though we've got more than, I guess, more than 3 distributions of each term, but it's the same concept. X times 2x squared, that's 2x to the third power. X times a -3x is -3x to the second power. X times 1 is going to be just x. So that is basically everything up here. Okay? The bottom half of this, taking -3, remember it is a negative that you're distributing, multiplying it by 2x to the second power. That's -6x to the second power. -3 times -3x is going to get you positive 9x. -3 times 1 is -3. So you'll see that it's the same as FOIL, it's just doing it more than one time. On the bottom, this is where all the green responses are coming from. On the top is where the blue responses are coming from. And then we just got to combine everything that's alike, and we're good to go. We got 2x to the third. I don't think that combines with anything. We've got a -3x squared and a -7x squared. That's going to combine to make -9x squared. We've got a positive 1x and a positive 9x's. That's plus 10x. And the only thing we have left is -3. Complete answer. All right, so just like foiling, okay, just maybe a little bit more involved because you've got more terms, but general principles is that everything in this term multiplies by everything in this term. Okay, and then combine what you can. I think that'll be it for today. I don't think we need to do any of these examples. Hopefully the video was helpful. Again, out today, but you guys can use this video as you see fit. Pause it, take notes on it, rewind it, whatever you need to do. All right, folks.